Also understand the accent as well. So yeah, as introduced, Mark Roberts, Market Development Director for BP Castrol. We're going to look at some of the insights and considerations for liquid cooling deployments as we've been working in the ecosystem over the past 12-18 months. So without further ado, I'll move on, and I'm actually going to start with a question I posed in Mumbai November last year. So it's a little bit of a test between you guys in Chennai and Mumbai. So in liquid cooling, should the actual fluid have direct contact with the IT equipment? So you can see the options there. So number one, yeah, let it swim like a fish. Two, no, that server's worth 300K. It's not going anywhere near that fluid. Don't ask me, just throw more air at it, or it depends. So hands up for A. Okay, B, C, and D. There's a lot of people that didn't put any hands up there. So yeah, it very much does depend. So we'll talk you through that. And in terms of what we're going to do from a agenda point of view, we'll take you first of all through the liquid cooling landscape, how we see it today. Then we'll dive into those considerations, and then we'll just talk about, obviously, I think most people know Castrol. We'll talk about our position within that ecosystem. So this is a study that came out from Omdia about 12, 18 months ago now, and it gives me three critical insights. The first one is that, as you can see, air's not going away. Okay, air is still very much going to be part of the cooling ecosystem, and in fact, it's going to grow and grow by almost double to what it is today. So that's the first takeaway. The second is we're very much at the start of that growth period for liquid cooling, and when we talk about liquid cooling, we're really starting to see it coming out of those specialized HPC environments, the crypto environments, and starting definitely to move into the data center, especially with the DLC. And the third one really is that growth within the liquid cooling that you see there is coming in a market that is going to double. So it shows how much of an impact it's going to have within the industry. When we talk about the different technologies, immersion and DLC, everything really, about 90-95% of that liquid cooling market today is direct to chip. We see immersion really coming along in the next 2 to 3 years. Okay, so that gives us a snapshot of where we're at. But what it's very much telling us is that we've got a tsunami of liquid coming, and we need to understand it and how we're going to deal with it moving forward. So one of the best things about my role is the collaboration piece. I've never seen it in 20 plus years within the data center industry. We always wanted to keep all the information to ourselves, but that's just not possible in this kind of scenario, because when we're dealing with racks that are worth $5 million, we need to make sure that everybody's working in harmony in order to make sure that all the deployments go smoothly. And you'll see I actually put the fluid right bang central in that ecosystem as well. And that's because of the critical nature of that fluid, and I'll explain that in the next couple of slides. But from the kind of people that we engage with, you'll see on our stand today, we've got an immersion tank, you've got the fluid in there, you've got the chipset, so we've got some silicon from Intel in this experience, we've got a Cisco server in there, we've got components in there. So when we're immersing, we need to make sure we're using the right fiber connection, Ethernet connections, et cetera, et cetera. And then we deal with the cooling vendors. So you've got a number from Schneider and Stultz and GRC on the immersion side today. We work with all of those guys because our fluid touches all of their components, and we need to make sure that we're playing nicely together. And then we're into the systems integrators. So those guys that are bringing the IT and the OT infrastructure together, because that is very much an evolving area. And then we move through to the actual deployment side. The mechanical contractors, they may be using fluid for the first time, or these types of fluids. The data center operators, all of a sudden we've kept fluid out of the white space for all these years, and now we're talking about putting it back in there. So we need to understand how we deal with that. And of course, the facilities management, and we'll talk about the importance and the criticality of actually maintaining the fluids in that ecosystem. So, as you mentioned, you've probably come across the immersion and direct chip cooling technology. One you might not be as familiar with is precision cooling, which is a bit of a hybrid of both, still using a dielectric fluid, but an area that is very good for edge environments. And the other one that I point out here is single phase and two phase. So the market today is very much dominated by single phase cooling as opposed to two phase cooling. And one of the primary reasons for that is, so in the single phase, the fluid always remains as a liquid, okay? So during the whole cooling process. With two phase, it starts as a liquid, and when it hits the heat, it transfers into a gas, it boils off, and then when it's cooled down, returns to an actual fluid again. It's got a huge benefit. It's actually about double the heat transfer capacity. So people might think, well, why aren't we just doing it? One of the challenges around the sustainability, it uses refrigerants, and there's some questions around that sustainability on the fluids. There's some arguments and counter arguments, but for that reason, at the moment, especially the big hyperscalers, they're playing it safe, and they're working on the single phase kind of technology. But I do expect two phase to come through more and more in the next couple of years. Just a few points on the different technologies. So obviously DLC, it is far more efficient than air. We know that. It enables us to reject between 70 and 80% of the actual total server power or server heat. Densities, we know there's so many NVL72s at 132 kilowatts being deployed around the Asia Pacific and in India as well at the moment. And one of the reasons for its adoption is that it's more of a familiar technology. We operate with the IT in a very similar manner to what we actually already understand in the data center. And the data centers are positioned to adopt this technology pretty easily today. So some of the challenges to be aware of, I view it as a little bit of a complex setup because we've got multiple different players in there. We've got the cold plates on the GPU, we've got hoses that connect to a manifold, the manifold's connecting onto valve set, header pipe work into CDUs, and within the CDUs we've got very different components in there as well. And we're expecting all of this to work nicely together, and we're going to put a water-based coolant in there, okay? So you need to be aware of these things. The immersion cooling, this is actually has some benefits in terms of it's going to capture all of the cooling. So it's very comprehensive in that heat capture. One of the challenges is, that means that you don't necessarily need any additional cooling. The only additional cooling you might need is for us as people for comfort cooling. Arguably reduced complexity. You'll see even on our stand, it just comprises of a stainless tank, it's got a heat exchanger, it's got a pump. Those units, whether it's a small one like that on the booth, to units that are as big as 375 kilowatts, they follow the same principle. So the actual complexity is reduced. It also has some benefits in terms of reduced or increased reliability of the IT infrastructure. We're taking away fans. We know fans fail. So that's one of the key things. We're reducing the actual moving components in the server. That helps us to increase reliability. And one of the benefits in an edge scenario, where if you've heard GPUs running, they literally scream, because it's in the fluid, there's a noise reduction as well. So you might actually wonder, why aren't we all doing it today? And that's quite simple, the hardware warranty. So the likes of the Dells, the NVIDIAs, today they're focused on worrying about DLC. And for that reason, they're not actually warranting the product. They are working on it, but it's not highly visible. And we expect that that kind of technology will be warranted in the future. The servers aren't optimized. We're just converting air-based servers to liquid. Next, we're starting to see the new types of server configurations and structures and architectures. And also the unfamiliar maintenance procedures as well. So I've got a lot of grey hair. So I used to walk up to a server, pull it out of a rack, and work on it. Now I'm pulling it out vertically out of oil, and it doesn't quite compute with me. So we're having to overcome some of these prejudices and teach people how to work with this kind of technology. And we're also working on standardization. We lead a number of different OCP work streams, both on DLC and immersion, and we're trying to drive some of that standardization. So let's look at some of the deployment considerations. I'll just take a drink because I've been talking all day. First thing you need to know, you've just introduced a single point of failure into your data center. Okay? We build up all this redundancy in power, we build all this redundancy in cooling infrastructure, and remember when I said I put it in the middle? That's because there's only one fluid. So the health of that fluid is absolutely critical. This is not a fill it and forget scenario. You need to understand it, you need to maintain it. So managing that, as I say, is critical. It's not going to be black and white. It's not going to be good and bad. It's going to change over time as it wears, similar to an engine cooling, arguably. But you will need to monitor it and also maintain it. So that should be known. If you don't, then that fluid in a degraded condition is actually going to reduce your cooling capacity. It's going to increase your power consumption, and it's going to lead to those early failures of your equipment. So it's key that you're doing this. Things like condition-based monitoring, so dynamically monitoring the fluid in the same way that you're doing the monitoring of all the other parts of your data center, and your preventative maintenance regime, lab analysis, etc., etc. So that's the first one. CFD. Simple things like pipework and the interaction of the fluids with pipework. Some of the work that we've been doing in our labs and with different parts of the ecosystem, we always know CFD from air in data centers, but now we're actually using it to mitigate risk with fluids as well. So with DLC, when we actually introduce a water-based coolant into the system, we're going to increase the flow resistance and we're going to reduce the thermal conductivity. Okay. Now, what that actually means is that if we use the CFD kind of tools, we can model the thermal and mechanical stresses that the pipework and the cold plates, the CDUs will come under at different stages, and we can predict and mitigate those losses. The other one that I always like to point, this is just a header pipe with the offtake here. And what you're seeing here, because we're dealing with high velocities that we'll talk about in a moment, we've got a sharp bend, 90-degree bend here, and the fluid's actually in turbulence. So that's got the potential to actually create corrosion, cavitation, which obviously you want to avoid. The other thing is that in here, the temperature is very different to here. And it's what we call a potential area of low fluid residency. And when you've got that, you've got the potential for biogrowth. And I'll show you the impact of that as well. Immersion, we can do it as well. We can use it to actually predict how an immersion tank might work at different performance levels, if we're driving for performance or if we're driving for efficiency. So we can do different scenarios. We can also analyze different temperatures of components, so, such as the GPU. So if we want to drive it to the absolute maximum without throttling the GPU, we can simulate that without actually going and syncing a 350K server. And it also enables us to, if we haven't got the full tank, where should we position it? Should we put blanking plates in like we do with air today? So all important things. We mentioned the fluid. And we mentioned the change, and that is certain. The fluid chemistry will change over time. I mentioned all those different wetted materials that it's going to come into contact with. It is absolutely critical that the right materials are selected all the way through that ecosystem. I've already heard of one water treatment company that took 169 samples, 75% were out of scope. So you can see the challenge we've got here. Another one, a social media platform in the US, selected the wrong hoses. They started leaching the plastic into the fluid. Again, critical to select those. And also in terms of making sure your glycol concentrate. So the glycol's there really for two reasons. One is to prevent, at 25%, it really protects against biogrowth. And what does biogrowth look like? That on the right-hand side is a magnified image of a cold plate where the water treatment or the treatment of the fluid hasn't been correct, and that's biogrowth on there. So you can imagine underneath the reduction in cooling capacity, and that's going to end up burning out. Obviously, these GPUs aren't cheap. So make sure we do that. People often don't realize there's actually a lot of fluid going to be in this data center. When we're talking immersion, we're talking about roughly 1,300 liters per 100 kilowatt tank. So when we extrapolate it out, that's about 13,000 liters of oil, although it's dielectric, in a megawatt facility. Okay, so that's something we need to start thinking about. Whilst the DLC technology isn't as much, the flow rate here is quite interesting to understand. So there's a rough, for any consultants in the room, I'm sure they'll concur, there's a rough rule of thumb that it's 1.5 liters per minute per kilowatt. Okay, so when we step that through, 10 kilowatt rack or 10 kilowatt server, that's 15 liters, not that much. But then we start going into 150 kilowatt rack, okay, 150 liters per minute, 2.5 liters per second. And then with the latest announcements from Mr. Huang and NVIDIA of 600 kilowatt racks, we're now potentially talking of 900 liters per minute or 15 liters per second. So all you data center operators, enjoy. So we need to make sure that we're going to understand how we're going to get this fluid in, how we're going to get it out, how we're going to deal with it when there's a spill. It's mechanical infrastructure, it's plumbing, it's going to happen. Okay, so be prepared for it. It's already happening, I can assure you. So we need to understand that, and we need to make sure that if there is, or if there's a problem with the fluid chemistry, where are you going to have the fluid? Like, with your crack units or your UPSs, you've got spare parts positioned, either at the facility or with the vendor. You need to make sure you're doing the same thing with fluids as well. I saw some of Venkat's presentation earlier on from Schneider, and he was talking about, obviously, the impact of AI. And this is something that has really come out in the last 6 to 9 months as people have really started deploying at scale. And this is what we term building a buffer, especially within the white space. And many of you will know that, like, if you don't have the right temperature and flow rate going over the GPU, it will have problems very, very, very quickly. So we need to make sure we're consistent with that cooling infrastructure. GPUs, there's an inrush. So when it initially kicks off, 170 to 180%. Okay, so you need to understand what impact that might have on your infrastructure, both power and cooling. It also, with the AI workloads, this is probably the most important piece. They have big swings. So a gentleman from Oracle that I did a presentation with, he was telling me that typically an AI workload might work for 5 minutes at 90% and then drop down, have a bit of a rest for a minute, and then kick back up to 90% and then drop back down after 5 minutes for a minute to 30%. So let's build that out to a 100 megawatt data center. 30 megawatt, 90 megawatt, 30 megawatt, 90 megawatt. You can imagine, like, I feel sorry for the power guys, like how the energy provider and how you're going to deal with that on an actual a power side, that's difficult enough. Now we come to mechanical infrastructure. It's even slower. So we need to think how we do this. One very smart hyperscaler or social platform in the US, easy. They write a piece of code that means that the GPU never goes below 80%. Problem fixed. But you're burning all that power. So it's only a very, very short-term fix there. So what we're starting to see is the emergence of oversized pipework, typically the 6-inch pipes. Consultants now starting to use a little bit of pipe size to go into 10-inch to actually as the header pipes. And we're also starting to see buffer tanks. Originally, we always put buffer tanks on the primary circuit. We're now even talking about having buffer tanks on the supply and return on the secondary circuit, so the DLC side, as well as the primary side as well. So these are all things that we're only finding out by doing. And the final one is something that's really come about by some work that we've been engaged with from the hyperscalers as well, where they were looking at how they can mix different fluids when it gets to the data center. And this was all driven by one of the actual, when the servers are actually tested within the ODM or the OEM, they put fluid through. And they do that at server level, rack level, and each rack is full of about 12 litres of fluid, but they can never get all of it out, okay? Which means that when it hits these data centers, there's still maybe up to 2 litres of fluid in there. So 100 racks, that's 200 litres into a circuit. So how's that going to interact? So we performed some research for them, and what we found is that if on a basis of a 95%, 5% overall mix, that when we looked at the chemical and the physical properties of the fluid stability, and the potential for corrosion, there was no issues, okay? So there's some of the considerations. It's probably easy to ask the question, who doesn't know Castrol? Put your hand up. Okay, that was easy. So obviously as a large oil company, we started in immersion. We've got a couple of products within that portfolio. When we're talking immersion, you've got 2 basic levers. You've got viscosity. The lower the viscosity, the higher the heat transfer. The higher the heat transfer and the lower the pump power as well. So that's one lever, but it impacts on flash point. Flash point is where the fumes potentially catch fire above. So depending on the jurisdiction, you may need to engage with your different fire authorities on that. We launched our direct liquid cooling portfolio last year with our PG25, basically demineralized water, glycol, and an additive package. And we launched that. We're working with the hyperscalers on that today. But most importantly, you've probably seen through the presentation the key message around the maintenance. So we've stood up all those services for startup services, and then also your in-flight services, so the preventative quarterly maintenance, biannual lab checks, and then even fluid disposal into the future, because you will need safe ways to get rid of it. Hopefully, if I talk quickly, you'll let me play this video. It's just a 2-minute video, and this just reinforces the requirement and importance of collaboration. So we stood up this liquid cooling lab in the UK in July last year, and it's our commitment to the industry. So we work with all the different type of immersion companies, precision cooling tech companies. You'll see the precision here from Isotope. You'll see some tanks from GRC who we're here with today, so certainly come by and have a look. And this is where we're able to look at how we do material compatibility. We look at unlocking new performance with different vendors as well, on both the infrastructure side, but also the IT side as well. And it helps us to promote the immersion side, whilst we're also doing a lot of research into the DLC side of things as well, in how we can get better performance out of some of the water-based coolants as well. So these are just the final ones, and I know I'm over time, so I'll thank you very much. If you've got any questions, we are in the far left corner as I'm pointing now. So look forward to talking to everybody a bit later on. Thank you.